Okay, today we are going to see explanation for division of polynomial. But before we start, I would definitely would like to explain you basic arithmetic rule because this is where we actually start algebra. Actually, your entire algebra book or all the sums are depending on these two arithmetic rules. I have made two sections over here, as you can see, and you must be thorough with all this basic arithmetic rules at any point, because if there is even a bit of a confusion in case of these basic arithmetic rules, then there is a strong chance that you will end up with wrong calculation ultimately. And I mean, no matter how means however and how many methods or whatever you learn or practice, but these basic rules that you have to be very thorough with. So that is the reason why I would like to explain you this first before starting any explanation for any of the algebra chapter. Okay, so the first section is for, as you can see, for addition and subtraction. That means whenever you are carrying out addition and subtraction of any two integers, then you have to watch out for the sign, whether they are equal, okay, or they are unequal signs. That means if both integers are positive, as in this case, or both the integers are negative, then what do? We simply add the two integers, and whichever sign is present, if both integers are holding plus sign, then the final answer should be given plus sign. Okay, this way. And if both integers are holding negative sign, then the final answer should be holding negative sign. But if one of the integer is having plus sign and the other integer is having minus sign, as in this case, or first integer is having minus sign and the second integer is having plus sign, then the signs are of course unequal. In that case, what do? We subtract the two numbers, or you can say we can find out the difference between the two integers and then give whatever bigger number sign is present. For example, let me take this number, these two integers, minus 7 and plus 11. Now here definitely unequal signs are present for these two integers, isn't it? So what do? We first find out the difference. Now what is the difference between 7 and 11? Of course, the difference is nothing but 4. Okay. And what is a bigger number sign? 11 is a bigger number and it is having which sign? Plus. So your final answer should be holding the sign plus. Okay. This is how we always do it. Now in the second section, I have mentioned here multiplication and division operation. So if both integers are having plus sign or both integers are having negative sign, then the signs are equal. Then in that case, whatever operations we are doing, multiplication, division, whatever, then the final answer should always be positive. Okay. And if one of the sign is plus, another sign is minus, or first number sign is negative and the second number sign is positive, then the signs are unequal. In such a case, the final answer should be negative at any cost. So these are the rules which should be always perfect in your head. If you're applying any other method, I don't mind. But the thing is that you should always remember the logic behind it, which I have explained you just now, and you have to be very thorough with these rules. Not even a single answer should go wrong if the logic is clear in your mind. So please watch out for that. And now I will try to explain you this first 5 sums which are mentioned in the exercise 10.1. I have already written the solutions. Okay, so the first sum, as you can see here, 21m square divided by 7m. Now 21m square, that is why 21m square is written over here in the numerator part and 7m will go in the denominator. So in order to do the cancellation further, what we do is 21, we can split it as factors such as 3 into 7. Isn't it? 7 3s are 21. Similarly, m square can be written as m into m, okay, divided by 7m. Now you can clearly see all the factors so that you can cancel them. So 7 and 7 can be cancelled from both numerator as well as denominator, 7 by 7. Okay. Then here one more factor will get cancelled, m and m, and we are only left with nothing but 3m. Then in the second example, 40a cube divided by minus 10a. So 40a cube should be present in the numerator, minus 10a which should be present in the denominator. So here again we can split this 40a cube in different factors like this. So in this case, minus 4 is written separately into minus 10a. Now here actually see you can split it anyhow, but they have what here in this case means you can write it as 2 into 2 into that is 5 into 2, like that also you can split, no problem, it's absolutely not an issue. But right now what they have done is they have taken deliberately this factor, but that is not going to change your answer even if you find out all the prime factors of 40, no problem, you can do that way also. So here as you can see, and here a is also split, I mean a cube is also here, it is you can say it is mentioned in terms of two factors, a into a square. Now inside this bracket minus 10a and minus 10a, both these two factors are same in the numerator as well as denominator, you can, that is why they can divide each other, and you are left with only minus 4 into a square. Okay. In the third example, minus 48p raised to 4 divided by minus 9p square. Here what they have done is simply this 48 is kept as it is, and p raised to 4, it is split like this, p square into p square. That we can, I mean 48 is kept as it is. But again, you can also mention minus 48 as well as minus 9 in terms of all the prime factors, or if it is difficult for you. Otherwise, you can simply go on dividing by the common factor. So here what is happening, one of the p square will get cancelled from the numerator as well as denominator, and this minus 48 and minus 9, okay, both are having one common factor as nothing but 3. 3 3s are 9. That is why if I divide 9 by 3, then I will get the answer here in the denominator as 3. And similarly minus 48, if I divide by 3, then also I will get 16. 3s are 48. That is why here in the numerator what am I left with? It's nothing but 16. Also one more thing I would like you to note is here in the numerator as well as denominator, both the signs are nothing but minus, negative. So these signs also will get cancelled, or you can say just now I explained you the basic arithmetic rule that if both the signs are equal, then the answer has to be positive. Okay. And then the answer should be mentioned in terms of quotient. Now here remainder is in all these three cases, the remainder is 0, right? Because they are all divisible, and the quotient is mentioned here like this. Quotient in the first case is 3m, in the second case it is minus 4a square, and in the third case 16p square divided by 3. Now in this fourth example, again the same thing, 40m raised to 5 divided by 3m cube. Here again 40, it is mentioned in terms of two factors as 4 into 10. Okay, so 10m cube and 10m cube, these two common factors will get cancelled, and I'm left with 4m square divided by 3. And in this the next case, what is happening, there is a bracket over here, and since in case of first term 5x cube is present, and in case of second term 3x square is present. Now x cube and x square, out of these two, can I take out x square common? Yes, I can do that. So what am I left with? If I take out x square common, then inside the bracket what will be left? Nothing but 5x minus 3. Because whenever we are taking out any common factor outside the bracket, then what we are doing is we are actually dividing by that number. And let me show it over here. For example, if it is 5x cube minus 3x square, right? And if x square is a common factor, then I will be actually dividing by this x square while taking out common. So in case of second term, what will happen? This x square and x square will get cancelled. It will get divided completely. But here it is x cube upon x square. So after division, what will be left? Nothing but x. That is why inside the bracket 5x is left, and here in case of the second term only 3 is left. So please remember that in case if it is not clear to you what do we mean by taking out the common factor outside the bracket, that is the reason why I have explained you this particular thing, this particular step. And once we have done that, as you can see now here in the numerator x square, denominator x square, so it will get cancelled and I'm only left with this bracket, which is nothing but 5x minus 3, which is the quotient. Here again the remainder is 0. In the next sum also the similar thing will take place. Here p cube and p square is present in these two terms, out of which p square can be taken out common factor as a common factor. So again in this similar case it is, so after taking out 2p and also 2 also can be taken out common. So 2p square is a common factor. So inside the bracket after division what will be left? 4p minus 2. And after that 2p square and 2p square will get cancelled or divided from both numerator as well as denominator. So I'm left with only 4p minus 2, which is nothing but quotient. So far I have explained you these sums. Please go through this video and tell me if there is any doubt. If anything that you want me to explain again, then accordingly I will do that for you. And also one more thing I would like to tell you, that if you are finding these sums very easy to deal with, that means they are not so difficult, then in that case my suggestion is that what you can do is you can later on tell me any of the particular sum. If you want me to explain that also, you can let me know. Okay.